Welcome, everybody. Thank you for joining the Evernym Indy team's sprint demo. This is covering Indy Node and Indy SDK. This is our 22nd sprint this year. And we got a packed conversation we got a packed 30 minutes, so we're going to dive right in and get going. The first thing I'd like to do is take a moment to celebrate that the Sovereign Foundation runs the Sovereign Network. That is the largest deployment of Indy. It's a public global utility. It's a public network. And it is upgraded to Indy Node 1.6, which is fantastic. That's the first upgrade in probably 6 months. This upgrade includes a lot of functionality, a lot of hardening, a lot of scalability improvements, and we're confident that it can be used for some time to come as people move into production loads on that network. We do have a lot of work we want to do to get it to scale even further and to stay ahead of the growth curve, but we're excited to have this upgrade done, and it's ready for wide adoption. And we're looking forward to people getting it deployed into solutions that production scenarios and end user solutions as soon as possible. And we look forward to hearing news about that. So that's the introduction, that moment of celebration. So thank you, team, for all the work you did on that. I know it was a challenge to get the software out and then to get all the upgrades done. The upgrade proved challenging. There were a lot of machines in different states, a lot of stewards in different states, so we had to want to thank Mike specifically for walking people through and getting that done. Now this sprint, the Indy Node team completed nearly 50 story points. We need to close a few out, but a load of work. We talked about shipping the 1.679 release, and we actually decided not to. The upgrade of the Sovereign Network took longer to get through the process, the pipeline, than expected, and this release was going to upset the other one. So we're going to postpone that until early December. But we did fix some bugs and do significant testing to ensure that next release, to improve that next release. It's going to be a service pack level release, not a lot of new features, but a lot of cleanup and hardening. So we're looking forward to that. On the SDK side, team completed nearly 50 story points as well. And the goal here was to focus on getting the libvcx, Evernym's credential exchange library, verifiable credential exchange library, integrated in Indy SDK. To get that integration to work, we had to build a dummy agent that handles the agent-to-agent communication the way the Evernym applications do, which is different than the way that the reference agents in the Indy community do today. So we built this dummy agent in Rust. It's pretty minimal. It's just a basic cloud agent, and it allows people to do this exchange and show that libvcx works, and then we can evolve it to be interoperable with the other agents in the community. So we're excited about that. We also have a Rust wrapper that was contributed by another Evernym team, and we got that incorporated. And we did a bunch of CI/CD improvements to get everything working correctly, and we took some community pull requests, and of course some bug fixes. And again, we didn't do a release in November. We're going to focus on that release in early December is our current plan. And then we'll probably have another release in late January. That's the way we're currently thinking about things. So with that brief introduction to the sprint, Artem is going to show the dummy agent, and then we'll have Darko explain the key rotation in the CLI, and then we'll look at the Node team will share the recent load test results and the test pool automation scripts, and then we'll talk a bit more about what our plans are for the next sprints. So Artem, you can share your screen now.
Hello, everyone.
Sounds good. We can see your screen. Excellent.
Okay. My demo is about V6. V6 is a top-level library on libindy that implements credential exchange and grace process. So last time we worked on making this library public available for community, and the last step on doing this was creating a cloud agent. The only one cloud engine used to be available was Evernym private property, and we have implemented our own and placed it near this V6 in our SDK wrapper. It placed here. So this dummy agent is written on Rust, also in libindy and V6 to start. It's a simple HTTP server that can has two public endpoints available. First one is /agency that can accept GET requests and return just briefly information about HTTP server like the ID, VK, and endpoint. And the second one is agency/message. We can post any message time with V6 used for communication and handle it. So to start our agent, I should put cargo run and specify config. This config I would like to make log available. This config contains simple information required for forward agents like wallet credentials, storage information, etc. By default, it starts on localhost, and now this server has been started successfully. Next, I would like to demonstrate a little demo how to use V6 with these cloud agents and demonstrate little credential exchange scenario. I have two Python scripts. I have two actors, Faber and Alice, and I would like to issue one credential for Alice and then ask for proving some of fields from these credentials. So I have two Python scripts here. Also, I have documented this transaction to work with pool. And I already have some configuration how I can work with dummy cloud agents. It's URI, DID, and VK forward agent. So let's start. Here I have service started, first window for Faber and next for Alice. Okay, I start with one. Now scripts is doing provisioning. It's establishing connection with dummy cloud agents and getting configuration of this. This is done. Next, sorry, it looks like some problems. Let's try again. Okay. Okay. I have started server. Start Faber Python script.
So you know there's no fakery in this demo. You're doing it live.
Success. We have passed second step is prepare some information like schema and condition definition, and them has been successfully posted on the ledger. And next, Faber would like to initiate connection with Alice. Press enter. So dummy agent doesn't send these connection details manually. I have to copy paste this data and put it for agent next. There are different ways can be implemented here. So like sending SMS or email. Now dummy agent doesn't do it. So now I'd like to start Alice Python script. Firstly, it does same steps like in Faber 2, installing its own cloud agent inside our server. And now I paste connection detail. So we successfully installed connection. And I would like to issue a credential. And now once Faber script sending credential offer, Alice and credential request back. Credential successfully has been issued. Now I would like to ask for a proof. Proof request has been sent. Alice generated proof. Alice script is finished. Proof successfully verified. So we have the demo has been successfully passed. Now we used here our dummy cloud agent. It works fine. Also, I would like to notice that VCX library is an experimental state now. The communication protocol isn't finished yet, it's not in the final state. It can be changed later by community. And also to let know that there is a getting started guide related to the VCX. It can be found here. This getting started is similar to Indy SDK libindy getting started, but used VCX instead of libindy. That's it. Thank you.
That was great, and I really like that all the alice.py and the faber.py scripts you are using are in the VCX directory in Indy SDK under wrappers. It's the Python 3 wrapper in the demo folder. So anybody who wants to see exactly how that credential exchange happened and how that library was leveraged can go through those scripts. So thank you, Artem. That was really good. So Darko, you ready to share your screen?
Yes, just a second. Do you see it?
Yes.
Okay, I prepared already IndyCLI keys wallet and the pool. It is all like usual. So the thing I want to demonstrate is resuming rotation of the key. So that may happen, for instance, when you're rotating key if a network is unstable and some packets are being lost, so you end up in some strange situation, not knowing if update of the key is written to the ledger or if it is written, if you didn't get a response, which where key you should use. So to demonstrate that, I will first change my network to dropped packets, and if I try it rotate key, it will fail after some time because of timeout. It should be pretty soon. Okay, and error will suggest to use the rotate key resume shrew to complete. So if I now fix the network like normal, it should work. I will just export the wallet here because I would need it for a second step. Okay, and if I now try resuming this rotation, that will succeed, and you may also see the current var key on ledger, current var key in the wallet, and temporary key in the wallet. So rotation succeeded, and you see that on ledger wasn't updated, so key on the ledger was still old keys. So I want also to simulate a case when ledger is being updated, but we are not getting response. To do that, I must I will delete the wallet. And import previous backup, which is Okay. Now in my wallet, rotation is not finished, but because we finished on the ledger already have latest keys. So if I try resume now, it will again succeed, and you may see in the log that key on ledger is a temp key in the wallet. So this is the second case when a packet is being lost from the ledger to the client. And also, if you try resuming without start, it will give you the error that resume is not started. So that's pretty much of it. Do anybody have some questions?
You're breaking up.
That's excellent. Thank you for sharing that, Darko. It's great to see exactly how to do that on the command line. I've been asked that question and glad to know how it works now.
Okay, thank you.
So Vladimir.
Hello. Let me share my screen. Hello. Can you hear me?
Yep. And we see your screen.
Okay. We have performed a bunch of load tests during the last sprint. So I want to tell about some performance results. The first, we ran 3 days AWS load test against 25 nodes pool, and we sustain 10 NIM transaction per second load for more than 3 days, and we reach more than 3 million transactions in the ledger during this test. So there is some unexpected behavior, so we can see that the memory grows at the all time of this test.
Sorry, Vladimir, we can't see the picture that you opened. Explorer. Maybe you can share your full desktop.
Okay.
Not just one window.
Mm-hmm. I should select desktop.
Yeah, we were seeing Windows Explorer before, so.
Can you see?
Yes, now we're seeing her. Okay,
yes.
good.
Okay, so we sustain this load, and we achieve a new big number at our domain ledger. Also, there is another long load test. 7 days in. It lasts for 7 days in Docker pool against 4 nodes, and we reach more than 6 million transactions in the ledger, and we see that memory consumption grow even after a week, but over time this growth becomes just slower, and memory consumption for database indexes grows linear during all time of this load test. Also, there was another set of load tests about ZMQ connections handling. There were 2 tests with activated firewall and without activated firewall. So we can see that client stack restart without limitation of number of client connections by firewall does not help us to avoid out-of-memory issues during DDoS scenarios like more than 100 transactions per second. So we can see in test with IP tables that during load of 100 NIMs per second, we see about 20,000 request queue size and about 200 simultaneous client connections. And in test without IP tables activated with the same load rate, we can see about 1 million request queue size and more than 1,000 simultaneous clients connections. Also, there was another load test with fees, and fees load testing shows us that we spent about 5 times more time to process our requests, and comparing if we send, for example, just NIMs and NIMs with fees. So this load testing will be continued in the next sprint, so we should measure it against all transaction types.
So what are the key conclusions from these 5 different kinds of tests, in summary?
We have our memory consumption grows at all load tests.
Let me just quickly share the main results. So the first result is that Zerium Q is really by design requires a lot of memory. It's not a memory leak, it's just architecture of Zerium Q. That's why we think it's not appropriate for client communication. The second thing is that we hope that by some strict aggressive limitations on IP tables and starting of client stack, we can somehow deal with this limitation of Zerium Q and can survive better during denial of service attacks, so they don't fall out of memory, and somehow restrict the client request with IP tables. This is what Vladimir showed. The second result is that even with a normal load, we still see a bit increasing of memory used, and there are 2 main reasons here. The first reason is Python, because Python by design, it may not release the used memory to the system, so it's normal that long-running programs written in Python may show this behavior. And the second very important result here is that we can see that RocksDB actually uses quite a lot of memory linearly. And one of the tasks for the next sprint is to restrict this parameter in RocksDB so that it doesn't linearly use the memory for indexes, and we have some upper bounds there. So for the next, in other words, for the next sprints, we have 2 main tasks. The first one is for Zerium Q and IP tables to find out the recommended numbers for firewall, and deal with denial of service attacks so that Zerium Q doesn't take so much memory. And the second task for the next sprint is to limit RocksDB settings. As for the fees and this kind of thing, yes, we can see that without fees, validation of NIM transaction takes about 2-3 milliseconds, and with fees enabled, it's about 10-12. So it's 5-7 times more. So this is the current result.
Excellent. Thanks for summarizing that, and thank you, Vladimir, for putting all this together. It represents a lot of work, and it's nice to see that we're being really analytical as we work the problem and to decide how best to improve the system.
Okay, thank you.
And Sergey.
Yeah, hello, do you hear me?
Yep.
Great. I'm going to present our new scripts for pull automation. As a background,
Are you sharing your screen, Sergey?
Not yet.
Okay.
And now I'm sharing my screen.
And it looks good. Thank you.
Great. Well, a little background. We need to run some pretty large-scale tests on, for example, 25 nodes pool, and it's quite expensive thing to do because we either need to have one pool. One permanent pool, which is really expensive, or we need to bring pools up and down, but manually it takes a lot of time. So we came up with some scripts to automatically do this thing. I'll try to show how to use them as quickly as possible. So the basic workflow is to start some experiments by running script inventory init. It just creates a directory with the name of experiment. In this case, it's just S. And the most interesting thing is config, which is commented out because it's because all values are by default, but in this experiment, I'll limit number of AWS regions, and I'll increase instance count to, say, 16. And next thing to do is to actually create a pool for this experiment. And now we can see that Ansible is Ansible created key pair, it's uploading public keys, and then it's going to create security groups and then spin up instances. While this happens in this console, I'll show that it's really possible to run multiple experiments in parallel. So I'll just create another experiment, and you can see that there is another directory. I'll also limit number of regions. I'll increase instance count to, say, 8. And I'll run poll create for another experiment. Meanwhile, we see that for experiment X, the script is already creating instances. And if we take a look at AWS console, we can see that instances are really created now. And these instances are for namespace X for experiment X. At the same time, more instances are created and for experiment Y, and we can see them. And it seems like time is up for this presentation, but it's possible to install Indy Node, and it will be a working installation, and the whole process of bringing up 25 nodes in all AWS regions is just about 10 minutes. So with these scripts, we can really bring up and down pools as needed really quickly. So that's all. If you have any questions, I'm open to answer.
Can you go back to your console again?
Could you repeat, please?
Can you go back to your command line, to your console?
Yeah.
So the code lives in the Indy Node directory, in the Indy Node project?
Yes, it lives
in pool
here.
automation. Okay.
Yes.
Excellent.
Actually,
Sorry, I didn't mean to cut you off.
oh, no problem.
Okay, I do see it in master. Yeah, so pool automation. So that'll be really useful for people to play with those, and they're based on YAML. Sorry, on Ansible. So that's great. Thank you very much.
You're welcome. Thank you,
So
Tom.
we're a little over time. I just want to really briefly explain a couple things that changes to the project going forward. With the successful deployment of Indy Node 1.6 on the sovereign network, Evernym's achieved our goal of having a public ledger that people can start using to build solutions, self-sovereign identity solutions, and we're really excited about that. With that, we've got a couple key changes. The first is that it's time to start thinking about what does this ledger look like in the future? How do we evolve this ledger to scale to the global population, billions of users? And we've been calling that Ledger 2.0 or a brave new node. What does it need to look like? How will it behave differently than Plenum and Indy Node do today? If you would like to be part of that conversation, we've been having it in the sovereign community because there's some people there that don't participate in Hyperledger Indy that have done research in this area. So that's on the sovereign Slack, and you can reach out to me or reach out to us at chat.hyperledger.org or chat.sovereign.org, and we can help get you into the right channel. It's the Ledger 2.0 channel, 2_0 channel. So we'd love to talk about that with you. It'll take some time for us to decide on what we want to do going forward. So this isn't driving short-term changes. We expect there to be a few months of research, but sometime next year we need to start implementing, early next year, first half of next year, we need to start implementing whatever is going to be the future of this project. So we're excited about that and encourage you to participate. And of course, you can reach us at chat.hyperledger.org in the Indy Node channel, or to have more of those conversations. The second change is Evernym's shifting some of our engineering resources. We've had a lot of engineers working on our contributions to Indy in order to get to this point, and we're going to still keep a dedicated team. Most people that have presented recently, and we're excited about being able to move forward with this project. But many of our other team members are going to move on to other projects as Evernym focuses on our applications that we want to sell on top of the sovereign network. So expect that change. We'll feel bad not working as closely with some of our colleagues, but we know they're going to do great stuff. And over time, the beauty of open source is we're all working and building an ecosystem together, and we expect we'll continue working together over the long haul, even though we get different projects in the short term. So with that, we are out of time. You can reach out to us. I'm Esplinar at chat.hyperledger.org or chat.sovereign.org. You can find me there. And of course, the other members of this team are happy to answer questions. So with the next sprint demo will be on the Thanksgiving holiday. So I'll be enjoying a big dinner with my relatives, but most of this team's in Europe, and they'll be on and be able to have that sprint demo, and we'll get that posted shortly after. So thank you very much. Thanks for everybody who prepared a demo. With that, I'll stop the recording.